ओके सो ये जो सेकंड चैप्टर है हमारा मोमेंटम का सही है इसके अंदर वी विल गोइंग टू डिस्कस द linear momentum, basically the linear momentum in one dimension and two dimension. Okay, and by the way we have two type of momentum, the linear momentum and the angular momentum, but angular momentum is not in our syllabus, वो आप यूनिवर्सिटी के अंदर जाके पढ़ोगे सही है. So we only have to concern with the linear momentum. Okay, and the date is 30th of August 2025. Okay. Now, in momentum, acha, if you consider it with respect to paper, so it is like, अच्छा हम किस कलर से लिख रहे हैं, पिछले उसमें ऐसे लिख रहे हैं और ओके. सो अगर आप इसको पेपर के रिस्पेक्ट से देखो, सो इट कंटेन एटलीस्ट 5 to 7 marks, 5 to 7 marks of in unit 1. Okay, comparatively an easy chapter, and the further extension of this chapter will be in unit 4, but it is like approximately the same, right? So let's first start with a basic concept of momentum. Okay, so momentum is, can anybody tell me what is a momentum actually? Anyone?
Mass in motion,
Mass, what, mass and
like mass in motion.
mass in the motion. Okay, okay, fine. Anybody? Anyone else? किसी और के जहन में कुछ? हम इसको एक दो तरह से डिफाइन कर सकते हैं. वी कैन डिफाइन दिस एज द प्रोडक्ट ऑफ mass and velocity. Okay, we can also define this as the measure of motion and inertia of the body. Yeah, measure the motion and inertia in the body, in the body. Okay, in the body. Okay, but the first definition is like more related with your paper. The second definition is like it cover a vast concept. Okay. Okay. So we know that the formula for this is momentum is equals to mv. Okay, and since v is a vector quantity, velocity is a vector quantity, so the momentum will also going to be vector in the same direction with the as of the velocity. Okay, and it is a vector quantity. Can anybody tell me its unit, please? Yes, can anyone tell me the unit? Yes, anybody?
Sir,
Kilograms
MS
meters per second.
ms-1 कौन कह रहा है? खदीजा आप कह रही हो?
मैंने MS बोला.
ms.
खाली
ओके.
MS.
ओके, और जैन आप क्या कह रहे हो?
Kilograms meters per second.
ओके, एंड अहमद व्हाट यू सेइंग?
Yeah, same as Zen.
सेम. एंड नूर व्हाट अबाउट यू?
80 meter per second.
Fine, perfect. So so we have, if you look at the quantity, so it contains the mass in kg and velocity in meter per second. Okay, good. So kg meters per second. Okay, perfect. Now So basically, momentum depends on the mass and velocity. So if you have greater mass, then it will going to be a greater momentum. If you have a greater velocity, so it will going to be a greater momentum, right? Like if you consider an elephant just walking toward you, since due to the fact that it has a very huge mass, so it will going to have high momentum or greater momentum. And similarly, if you consider a bullet being fired from the gun, so it will again have a greater momentum, but the mass of the bullet is like really small. It is like in grams, but due to the fact that it is fired with a very high velocity, so it will going to have a very large momentum. Okay, but the effect of the momentum can only be understood by the concept of, or by the presence of the collision. Okay, like if something collide, then you can understand, or you can imagine how much the momentum it has. Okay, so ये basically simple सा concept है. But we since we have two types of momentum, the one dimensional momentum and the two dimensional momentum, so let's first discuss the both of the momentum, and then we'll move on. Okay, so actually one dimensional momentum. So okay, and we have two dimensional momentum. Dimensional momentum. Okay. So in one dimensional momentum, let's say if you have an object, if you have an object and it is moving, let's say with this in this way, with a velocity of 5 meters per second, having a mass of 3 kg. Okay, so you can easily tell that the momentum is going to be mass times velocity, and mass is 3, velocity is 5. It gives you 15. So 15 kg meter second negative 1. Okay, and since the momentum is a vector quantity, so the direction is rightward, right? So this is one of the case. Okay, but if you have the two-dimensional scenario, then let's say the object is like this. Okay, and it is moving in this direction. Okay, moving in this direction with a velocity of 6 meters per second, let's say, at an angle of 30 degree, let's say 30 degrees. Okay, at an angle of 30 degrees. Okay, so in this scenario, it will going to have, since it is a two-dimensional momentum, it is neither in the horizontal direction nor in the vertical direction. So it is in between, which means it is also moving in x direction and also moving in y direction. Okay, and if this is the case, then you have to break the momentum into its two components. Okay, the concept of the components we discussed in the previous chapter as well, and it is like simple. It is a simple thing, as you can consider it. You can just break it into the into its parallel and perpendicular components, right? मतलब हमने ये कहा था कि भाई all the vectors that are in diagonal form in between x and y are always made up of a horizontal component and a vertical component. Okay, and a horizontal, that in the horizontal component, vertical component can be written as 6 cos 30. Okay, and vertical component can be written as 6 sin 30. Okay, 6 sin 30. क्या इसमें किसी को कोई प्रॉब्लम है? Anybody? Is that clear? Yes, please कुछ तो बोल भाई.
जी
ओके भाई, अच्छा जी बता देते हैं. सो एंड यहाँ पे हम ले लेते हैं 3 kg. सही है. देखो हमने ये कहा था कि भाई देखो, इफ यू हैव अ वेक्टर, if you have a vector in this direction, right, you can simply solve it. Okay, but if you have the vector in this direction, you can simply solve it. Okay, but if you have a system that contain either these two vectors, okay, either these two vectors, or that contains something else, like if the object is under the influence of this vector. Okay, so in this case you are not allowed to simply add or subtract them. Okay, because vector is like, by the meaning of the vector, it contains the direction as well as the magnitude. So the vectors that are not in the same direction or in the opposite direction, you cannot simply add or subtract them. You have to consider their directions while adding or subtracting. Okay, so for this case, you just simply apply the Pythagoras theorem. If let's say this is P1 and P2, so you do P square, P1 is squared plus P2 is squared, and whole thing under root to get the resultant vector, right? So this is the first concept. Okay, and you'll get the resultant vector. Okay, and the resultant will going to be in this direction, right? Making sense, guys? Yes. नूर एंड खदीजा, तुम दोनों को शायद ना समझ में आ रहा हो, ये मुझे बताओ, ये चीज समझ में आई? वेक्टर्स की वाली कहानी अभी तक समझ में आई?
जी समझ आ गई।
जी सर।
ओके, सही है. So if you have two perpendicular vector, you have to apply Pythagoras theorem to convert it into a diagonal vector. Okay, and similarly, if you have the diagonal vector, you have to break down into perpendicular components. Okay, like you have to break it into a horizontal component and a vertical component, right? Is that clear, guys? Noor and Khadija, is that clear?
जी
जी सर।
Okay, now the question arises, why should we or why we are doing that? Okay, like अगर हमारे पास जो है वो एक diagonal vector है, why we are converting it into like its vertical and horizontal component? And if we have the vertical and horizontal component, then why are we converting it into diagonal form, right? So the answer is, if you have two vectors, okay, acting on the body, let's say one in this direction, okay, and one in, let's say, this direction. Okay, so, and I want you to find the resultant of these two vectors, right? So you know that vector quantities are having their directions. Okay, and without the directions, like without uh, they are in the same direction, you're not allowed to add or subtract them, right? So you can never solve these two vector by just adding or subtracting them together. Okay, so what you have to do is you have to break them into their horizontal and vertical components. Okay, this is a horizontal and this is a vertical components. Okay, say okay. And similarly, you have to do the same thing with this vector. Okay, just break it into horizontal and vertical components. Okay, now you can subtract these two vectors as they are now in the opposite direction, and you can add these two vectors as they are now in the vertical direction, right? So let's say when you add a vertical, so the resultant vertical is, let's say, like this. The resultant vertical is, let's say, like this much long, and when you subtract the two horizontal vectors, so you end up, let's say, like this. Okay, so now you are left with two resultant vectors, one in the x direction and one in the y direction. And then to find the overall resultant of the whole system, you have to convert this into the resultant vector by applying the Pythagoras theorem. Okay, is that clear, guys? So if you have a lot of vectors present in the system in the different directions, then you have to break it into the vertical and the horizontal component to simplify it, okay, to simplify them. And once you are done simplifying them, then you will end up with one resultant vector in horizontal direction and one resultant vector in vertical direction, okay? And for further simplification, you just apply Pythagoras theorem to get one resultant vector that basically reflect all the systems resultant quantity, right? Is that clear, guys? ये समझ गया है? नूर, खदीजा समझ गए हो? अहमद, जैन, everyone?
जी सर।
Perfect.
जी।
So okay, fine. So that is why we are breaking down the components into the vertical and horizontal. Okay. So, and that's why we just break, since the velocity is a vector quantity in the momentum, right? So we have to break the velocity only. Okay, so this is 6 cos 30 is basically the velocity component in horizontal direction, and 6 sin 30 is the velocity component in vertical direction, right? But if we want to find out the momentum in horizontal and vertical direction, you just simply need to multiply it with the mass, which is 3 kg and 3 kg. Okay. So then you'll get some answers. That will going to be your final answer. Okay. One in the horizontal and one in the vertical direction. Okay. Is that clear, guys? Is that clear? सब समझ में आता है? Everybody?
Yeah.
Perfect. Now, अब यहाँ से हमारे पास बात आती है कि भाई okay, if we have the we understand the concept of the dimensions in the momentum. Okay, now we have to consider the law, or we have to understand the law of the momentum. Okay, after which we can consider the different cases. Okay, so the law of conservation of momentum says that law of conservation of momentum says that, anybody remember? Can anybody recall the law of conservation of momentum? Anyone?
In a closed system, the total momentum before a collision is equal to the total momentum after the collision.
Okay, very good. Okay, any other? Yes, anyone? Any other? No one? चलो ओके, फाइन, सही कह रहे हो। थोड़ा सा हम इसको थोड़ा सा चेंज कर लेते हैं। हम ये कहते हैं कि भाई इन एन in an isolated system, okay, the total momentum of all the interacting bodies before and after the collision remains the same. ओके, ये हमने बात कर ली, सही हो गया। अच्छा जनाब, अब जो है यहाँ तक तो डन। इसके अंदर अब अच्छा, इसकी ना एक और डेफिनेशन होती है, हम उसको भी कंसिडर कर लेते हैं, सही है। और वो हमारे पास है, द सेकंड डेफिनेशन इज, यार मज़ेदार राइटिंग नहीं हो रही, द चेंज इन momentum of one object um, after the collision remain equal and opposite to the change in momentum of the other object. Okay, it seems like related with the Newton's third law, right? अच्छा, नाउ इसके अंदर जो हमने बात की है, वी डिस्कस द आइसोलेटेड सिस्टम। ओके, सही हो गया। एंड देन we discuss the concept of the total momentum. Okay, and then we discuss the concept of the collision. Okay, okay, and then we discuss the concept of the change in momentum. Okay, these are some concepts that we have discussed. Okay, अच्छा अच्छा ये एक चीज यहाँ पे और भी ऐड कर लो, ऑब्जेक्ट provided that no external forces are present। ओके, सही हो गया। सो ये हमने बात कर ली। अच्छा जी, अब आ जाओ, एक एक करके जो है ना सारी चीजें समझते हैं, और फिर उसके बाद जो है ना ये हमारा चैप्टर कंप्लीट हो जाएगा। ओके, सो परफेक्ट। खैर, अच्छा जी, लेट्स स्टार्ट विद आइसोलेटेड सिस्टम। सही। अच्छा देखो, आइसोलेटेड सिस्टम का ना, आइसोलेटेड सिस्टम का, क्लोज सिस्टम का, जो भी कहो सही है, उसका कॉन्सेप्ट ये है, आइसोलेटेड system। Okay, so isolated system always means, in this chapter it will always refer to a system with no external forces। Okay, right, एक सेकंड देना। अच्छा जी, सो आइसोलेटेड सिस्टम के अंदर कहा कि सिस्टम with no external forces। ओके, देखो फोर्सेस आर बेसिकली ऑफ टू टाइप, इंटरनल फोर्सेस एंड एक्सटर्नल फोर्सेस। ओके, इंटरनल फोर्सेस जो है ना वो आपको सिस्टम के अंदर पता नहीं चलती, सही है, उसका हम उससे कोई रिलेशन हमारा नहीं होता, राइट। सो इंटरनल फोर्सेस हैव नथिंग टू डू विद सिस्टम, राइट। वो इंटरनली किसी ऑब्जेक्ट के अंदर इंटरनली अगर उसकी इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन है, सो दैट डजंट अफेक्ट द एक्सटर्नल वर्ल्ड। ओके, मतलब लाइक इफ यू हैव अ सिस्टम and that contain internal forces, so internal force doesn't like, the way if you are sitting in the car and let's say the car breaks down and you want to push it to the side। Okay, so you cannot sit in the car and push it, right। उससे कुछ भी नहीं जाएगी, कार कहीं भी नहीं जाएगी, सही। but you have to step out of it and you have to push it to make it to the side। Okay, so ये हमारे पास जो है ना एक कॉन्सेप्ट होता है, सही हो गया। बस इस चीज़ को जो है ना तुम्हें याद रखना है कि टू मेक इट, लाइक जो एक्सटर्नल फोर्सेस होती है ना, एक्सटर्नल फोर्सेस का मतलब एक्सटर्नल फोर्सेस बेसिकली इफेक्ट जनरेट करती हैं, बट इंटरनल फोर्सेस डजंट जनरेट द इफेक्ट। ओके, लाइक इफ यू आर सिटिंग ऑन द चेयर एंड while sitting, if you try to push it in some direction, like if you try to push the chair while you are sitting on the chair, if you try to push it to some side, you cannot make it, right। तुम कहीं नहीं जाएगी आपकी chair, but if you are sitting on that chair and you push it against the wall or you pull some rope or something, then you'll move in certain direction। but if you're sitting on the chair and you apply to and you try to push the chair or pull the chair while sitting on the chair, nothing happens। Okay, so internal forces doesn't cause the changes। Okay, so there are only external forces that produces the motion or that stops the motion। Okay, and external forces are basically of two type। Okay, एक सेकेंड, ये जो है ना थोड़ा सा इसको हम यहाँ साइड साथ मिला लेते हैं, सही। So external forces are of the two types। Okay, one is where the system accelerates, you say it as the forward force, and the other is the backward force, okay, or the decelerating force, right? So now, so resultant forces can be of the two types, okay, the forward force, okay, the forward force or the backward force, okay. You can also understand this by a pushing force or a pulling force. Okay. So if you have the pushing force present in the system, then it will try to accelerate the object, or it will speed up the system. Okay. So the effect of this force is to speed up speed up the object. Okay. And if you have the pulling force present in the system, or the backward force present in the system, then it will going to slow down your system. Okay. Slow down your system. Okay. And since we are seeing that both the forces are not present, as the external forces are neglected, so we can say that the neither the system or neither the object accelerate or decelerate, or neither the object speed up or slow down. Okay, is the concept clear? अच्छा जी, मुझे 2 सेकंड दे दो, जरा अजान हो रही है। सही है, उसके बाद पढ़ते हैं। आ जाओ भाई। सो ये हमने देख लिया कि भाई ऑब्जेक्ट जो है ना तो स्पीड अप हो रहा है ना तो स्लो डाउन हो रहा है। ओके। और इसके बाद जो है, तो ऑब्जेक्ट जो है वो आपका मोमेंटम के अंदर जो है, अगर आइसोलेटेड सिस्टम होगा, सो इफ द ऑब्जेक्ट इज मूविंग, सो इट विल ऑलवेज मूव विद अ कांस्टेंट वेलोसिटी। ओके। एंड okay, the external forces are only present during the collision. Okay. Please keep this thing in mind. Okay. So external forces only appear during the collision. Okay, fine. So ये आपके पास हो गया। अच्छा जी, now this is done. The concept of isolated system is done. Now we have the total momentum. Okay, so the concept of total momentum is total momentum is basically, so so the concept of total is basically sum up the quantity or sum up the things that you have. Okay. So but since momentum is a vector quantity, so summing up the vector having a specific rule, and that is you have to add up all the quantities considering considering come on considering their direction. Okay. So this is the concept of the total momentum, right? So like if you have the system containing two objects. Okay, fine. And let's say in the first scenario, both the objects are moving in the same direction. Okay. having a mass of 4 kg and 2 kg with a speed of 5 meter per second and 3 meter per second. Okay. If I ask you to find the total momentum of the total momentum before, or the total momentum of the system, of the accelerator system, so you're going to say 4 times 5, okay, plus 2 times 3. And you will going to apply plus sign with both of the velocities, as it is a vector quantity. So 4 5s are 20, 2 6 is 2 3 is 6, 26 kg meter second negative 1. Okay. But if in the second case, if we have the same thing, but one both are moving toward each other, okay, then you can say that 4 kg and 2 kg, and both are moving toward each other, then you can say that you have to consider any direction. Okay. If you are considering this as positive, you have to take this as negative. If you do the other way, it is also possible. Okay. So if you do this way, so then you'll get 4 times okay, the velocities remains the same. Okay. 5 meters per second and 3 meter per second. Okay. So the 5 plus 2 times negative 3, you will end up getting the value of 14 kg meter second negative 1 with a plus sign in your answer. Okay. Or you have to mention the direction. Okay. Said okay, bhai. So 4 5 is 26. Okay. If someone consider the direction as opposite to what we considered, so he will going to get the answer like this, negative 14. Okay. But the interpretation of both the answers remains the same. Okay. Like this negative and this positive shows the same thing. In the first case we consider positive as rightward, in the second case we consider negative as rightward. Okay. So you consider it's up to you, you can consider anything, but you have to keep that for throughout the question. Okay. So this is the concept of total momentum. You have to you have to add all the things by considering their directions. Okay. And okay, so this is done. Okay, the concept of collision is very simple. It is a physical interaction between the two objects. Okay, but this is not necessary that only the physical collision or the physical क्या कहें यार इसको interaction means a collision. Okay, there are some collision that doesn't actually collide, but they rather interact without being collide or without being physically met with each other. Okay, like if you throw the two magnets toward each other, right? Two magnets toward each other with the same poles, like poles, so they will become closer to each other, but as they get closer enough, their magnetic fields will repel each other and they will like move away. Okay, so there isn't any physical collision, but it is rather an interaction. Okay, so collision is like the simple thing. Okay, but if we consider the collision, so so during collision, the contact force rises. Okay, during collision, the contact force rises. Okay, and with change, the velocities of the interacting objects. Okay, सही हो गया. So ये आपके पास हो जाएगा. सही है. And both will going to experience the same amount of force equal in opposite direction, right? Newton's third law. Okay, so both the object will going to both the object will going to experience the same amount of force equal and अच्छा same amount of force in the opposite direction, not equal, वो equal हो चुका है, same amount of force है, force in opposite direction. Okay, so this is the concept of the collision. Okay, and now we are done with the concept of collision. Now the last terminology is the change in momentum. The change in momentum. Okay, so change in this is something where most of the students did mistake and a very simple mistake. Okay, so let's say if you have change in momentum means like final minus initial. Okay, so if you have the momentum, if you have the object, let's say this is the object, okay, and it is moving in this direction, okay, and it is being hit by something or some wall or whatever, and then it is reflected back or and it is coming back the opposite direction, okay, okay, and let's say ऊपर वाला before का नीचे वाला after का है, and so let's say this is 30 meters per second, this is 20 meters per second, okay, and let's say the mass is 15 kgs, right? So if you have to find the change in momentum, so for the change in momentum, the object is the same, okay? So for yeah for wait for change in momentum, you just do, come on, change in momentum, you do final momentum minus initial momentum, okay, and this negative sign in between is due to the change, okay, and now you have to consider the velocity direction, one with a positive, one with the opposite, okay, and the first thing is the final momentum is going to be 15 minus 20, okay, 15 times minus 20 minus due to the change, and then 15 times plus 30, okay, and this will going to be in the change, okay, so if you do 15 times 20, 30, 300 and negative 300, okay, and that will be 3 times 15, 45, 4.5, 450, okay, and then you will going to add them both, so that will be 750 with a negative sign, okay, and this negative sign shows that the change in momentum, the overall change in momentum of this system interacting with the wall is in this direction, okay, is that clear? Kg meter second negative 1, okay. So this is the change in momentum of the ball. Okay, this is the change in momentum of the ball, right? If you want to apply the change in momentum on the system, then you can say that the change in momentum of the ball before and after the collision should be equal and opposite to the change in momentum of the wall. Okay, clear? So if we are saying the ball has an overall change in momentum in this direction with a magnitude of 750 with a negative sign, so the change in momentum of the wall will be in this direction. It will going to be the 750 Newton, okay, and with a positive sign, okay. So this way your Newton's third law hold, this way your law of conservation hold of momentum holds, okay. That the net momentum or the change in momentum of one object should be equal and opposite to the change in momentum of the other object, right? But since the wall cannot move, or since the wall does not have any velocity, so it will have the resultant force or it will have the overall effect zero, okay. But if you continuously hit the object with the wall, so the wall maybe break down or something, okay. So but yes, this is the thing, so change in momentum is also done, okay. Now let's try to understand the law of conservation of momentum in two examples. यार नमाज का टाइम हो रहा है, चलो बस करते हैं बस, ये एक चीज बाकी है इसके अंदर, आखिरी चीज है, application of conservation of momentum. Okay. अच्छा जी, ये बात हो गई है। अच्छा, अब आ जाओ, बल्कि अभी हम पढ़ नहीं पाएंगे। सही है, हमें बस दो चीज़ें देखनी है बेसिकली। सही है। द फर्स्ट थिंग इज द वन डायमेंशनल मोमेंटम को हम किस तरह से सॉल्व करेंगे, एंड द सेकंड थिंग इज कि जो टू डायमेंशनल मोमेंटम है, हाउ डू वी सॉल्व इट। सो विल लुक एट इन द विल कंसिडर दिस इन द इन टुमारोज क्लास, और फिर उसके बाद वो भी कंप्लीट हो जाएगा। सही, इसके अलावा और एनर्जीज का छोटा सा कॉन्सेप्ट है, उसके साथ जो है ना वो भी कंप्लीट हो जाएगा, एंड देन विल मूव ऑन टू द क्वेश्चन। ओके। सो कल इंशाल्लाह ये कंप्लीट हो जाएगा। बस आज की क्लास में ये तक करूँ। सही है। एंड आज की क्लास थोड़ी लेट शुरू हुई थी, दैट्स व्हाई ये नहीं हो सका, वरना इंशाल्लाह कल ये कंप्लीट कर लेंगे। सही है। सो बस चलें। चलें जी। ओके गाइस, टेक केयर बच्चों। अल्लाह हाफिज़।
ऑफिस।
अल्लाह हाफिज़।
Professor.
अल्लाह हाफिज़।